cover increasing resiliency of the applications that you build. This is actually part of a broader initiative we've had a little while ago of how, in general, you can build around Azure Active Directory with resiliency in mind. We actually have three broader topics within that category. First, we have some information on infrastructure itself. How can you best configure Azure Active Directory to make the most of resiliency? We also have another whole section on how to increase resiliency with respect to Azure AD B2C and the items that you can do there. And then the third topic is the one we'll be talking about today, which is doing it for applications. So you can look at one of those articles for more details, both of some of the topics I'm covering today, but also the other areas as well. And I'll post that. But those are our documentation on resiliency all up. What I'm going to talk about today is resiliency with respect to the applications that you create. And I'm going to break it broadly into two areas. First off, we're going to talk about applications where there is a user in front of the application and there's an authentication that has to happen for the user, as well as authorization to call various APIs. And then we'll talk about areas where we don't have a user in front, a service or a daemon of some description, and what you can do to increase your resiliency there. So let's first start talking about signing in users. Now, the premise here is that you have an application and you want to make sure that this application can be as resilient as possible to various issues that get between your application and getting a token from Microsoft Identities. As an application developer, both as a service or as a client app, your real transaction you have available to you with respect to how you interact with Microsoft Identity is getting a token. So at the top tier, it's a pretty straightforward concept. You need to ask for a token from us. You either get it and can proceed, or you don't get it, and therefore you would handle that failure gracefully with whatever fallback has to happen. But how can you be resilient to any kinds of interruptions that might happen between you and getting that token? Maybe there's a network infrastructure issue. Maybe there's an issue on our side with respect to our service. Maybe there's something in between that's going on. And obviously, we want your application to be able to work and keep working throughout any kinds of any of those kinds of interruptions. So the first bit of advice is something pretty generic for us, really, and that is wherever possible, you should use our Microsoft authentication libraries, because we do a lot of the best practices that we're going to talk about throughout the rest of the session. We already do inside of our MSAL applications. So the point there is to make it, MSAL tries to simplify you being able to get a token. We handle caching the token, we handle storing it, refreshing it, all of those things. And we always keep these best practices in mind when we do this. Also, on platforms where we know there exists a secure platform, so for example, on the mobile devices where we know how to store tokens securely, we'll go ahead and cache and store tokens for you automatically. And for those items where you have options of where you do your token cache and store, we provide guidance on how to best integrate with those. So for example, on the ASP.NET Core side, we have a number of different strategies you can use for respect to storing and caching your tokens. Now, what's interesting about MSAL is as it evolves, it's becoming more and more going past just sort of straight protocol level things with respect to best practices and picking up more kinds of optimizations around Microsoft Identity. And this includes some specific ones around resiliency. Now, we're always trying to be more performant and have new capabilities, but there are also some specific things that we're doing that MSAL will understand with respect to how to make your app more resilient. The first one is something called proactive token refresh. Now, with various new functionality that's coming up, things like continuous access evaluation, what we can do with a managed managed identity for Azure resources, we have found that we're able to extend our token lifespan. So As a developer, of course, you never will know exactly how long a token we issue will be valid for until you get the token, right? So you should never count on us being an hour-long token or a 5-minute token or a 2-day token or what have you. Obviously, we'll issue the tokens appropriately given the situation and the circumstances. But what we're finding is as we add things like the ability to invalidate a token, we can lengthen the default lifespan out tremendously. So first off, of course, that will help resiliency just because you don't have to ask for a token as often as needed for us. But if we can extend a token lifespan out from, say, an hour to a day, then we have an opportunity to also start, assuming various conditions on the service are being met, to inform your application that actually you can start to try to refresh that token early. So instead of waiting until the end of the token lifespan, we, the service, can send you the MSAL a notification that says, hey, I've given you a 24-hour token. Why don't you go ahead and try to refresh that token in 12 hours? Now, the nice thing about that is if I use a standard, I'm at the end of the token lifespan, I need to get a token within a few minutes in order to continue working. I effectively still have a token that's good for the rest of the 12 hours. So I gave you a 24-hour token, and we're going to send you a signal that says, hey, you could refresh it in 12. You've got a token that's still good for 12 more hours. So effectively, your application now has 12 hours to complete a token refresh. Now, obviously, most of the time that's moments, not hours, but it does mean that if there was any particular glitch in the network or some issue between you and your token, if you will, during that initial request, you've got more time in which case to pick that up, to actually get a fully refresh the token. So a proactive token refresh, it works in conjunction with the service to determine when those kinds of situations can work out. And obviously, we're building that capability directly into MSAL. Another big area for resiliency is we've already talked about very, very briefly in a couple of blog posts by Nadeem, our VP, about another Azure AD backup authentication service that we have under construction right now. This backup authentication service will usually kick in completely silently and automatically, and nothing you need to do to your application comes into play. And when that's the situation, everything will just work. However, there is a situation where we want to have the backup service in place should your primary path to Azure AD somehow get interrupted. So if we have our first hop, if you will, to a token request, if the first hop of the token request, which normally will figure out if it needs to go to the primary or the backup, if the thing that does that decision is down, MSAL will be able to find a way to the backup all by itself. So there's another big resiliency. So if there was anything problematic in accessing to the primary service, and even the gateway in front of the primary service that makes that decision, then MSAL will have an understanding of how to fall back to the backup, again, automatically. So using our MSAL or Microsoft Authentication libraries, especially if you're developing a line of business application, is a really great choice to really help with your resiliency as we do more and more work to beef up the resiliency capabilities within Azure Active Directory Microsoft identities themselves. So the next thing is I do want to highlight, and I'm going to bring this forward because we're going to do a little demo, and it takes a few minutes. So I do want to talk about continuous access evaluation. I did have a session in more detail on continuous access a little while ago that should be up on our published sites somewhere. But let me reiterate continuous access evaluation because it really is an enormous capability that's coming that is, in fact, already in Azure AD in a lot of situations. So you can develop your application to be CAE ready today. Now, continuous access evaluation has three components in play. First, the API itself is going to register in order to get events from Azure AD, Microsoft Identity, directly to the API about the state of any access tokens that have been issued for the API that are currently out in the world valid. So if you're an API, you can register that you're an API, and then you'll be able to at some point be able to get from us signals that say, hey, I issued a token for your API an hour ago. Please don't accept that token anymore. Or I issued that token a few hours ago. Please don't accept those tokens anymore. We'll go ahead and signal your API directly. So the first two components are Microsoft Identity and the API working in conjunction to determine what the validity of a particular token is. So we issue JSON Web Tokens for as access tokens to APIs. They're normally good until they expire, so they're good for as long as the lifespan of the token is there. But this gives us an opportunity for the Microsoft Identity to talk to the API implementation directly and say, yeah, don't accept that token anymore. Now, we don't have a way for you as an API designer yet, a developer, to be part of this process. We are participating in something called the Shared Signals and Events Working Group, and you can see our link to that here on the page. That's not a link to us, but to a working group where they're going to standardize that connection between an identity provider and an API implementation or resource so that these signals can be shared and there'll be a standard way to talk to the services. The standard's not quite ready, but we're going ahead and implementing it across our own APIs to begin with. So as soon as those standards are in better shape or a little more mature, really, they're in good shape, but as more mature, you'll be able to start participating as an API developer. The third piece is the client application itself. The client application has to be changed because it's now going to get a rejection, an unauthorized response to an API call when the client has what it believes is a perfectly valid JSON Web token in hand. The token response we gave said it was good for an hour or 24 hours, so it should still be good. So the client actually has to listen, and when it do that listen, hey, when you call the API may say, I'm no longer accepting that token, your access token anymore. The client will understand and know it needs to go back and ask for another access token. So we need the clients to be updated. And we have some guidance on the second link you see here on the page, the AKA-MS client CAE page. Will take you to how you could do that implementation. And finally, we are going to be enabling sometime in the next couple of months or so a private preview for Microsoft Graph APIs to participate in continuous access evaluation. And there's a link there that you can use to register that you would be interested, and we will reach out to you and see if we can work you into the private preview. Now, again, the nice thing about these tokens with respect to resiliency is when you use continuous access evaluation, we can now issue a token because it can be invalidated. The life of the token can grow to up to 28 hours. So instead of having you come back to the system every hour for a new access token, so at a normal working day, you have to go 8 times for someone who's using your app all day. Now you only have to go once because that token's good for their entire working period or in a full 24 or 28 hours of the day. And again, the MSAL will understand that when the server can give it the right signals, we could even go ahead and proactively refresh that token. So again, we give ourselves an enormous amount of time to handle any kind of variation or issue between you and your token. We can handle recovering from that and moving on where your application still has a valid token in hand and it may never notice any kind of disruption on the back end. So I think we have some questions. So yeah, we can't support the idea of Azure Active Directory supporting introspection is just too expensive for everybody. Every time you call Graph API or Graph API is different, but every time we call one of your APIs to require introspection, it is a very expensive process and therefore would slow everything down. So that's why we're not looking to implement token introspection ever. Our answer is to work through this continuous access and shared signals working group as our long-term answer to this process. Continuous assurance. I'm not sure what you mean by continuous assurance, Sahil. Feel free to come off mute or to type in more information in the chat. If you're looking for proof of possession of tokens, that's something else. I don't talk about it today, but there is work obviously going on to obviously strengthen token security. So you'll probably hear from us about that at some point. So let's take a quick look at continuous access evaluation. So I have a very simple application here. I had a very simple application here. Let me bring it up. Let's go ahead and start this. So it's a very simple app, and I'm just going to do a couple of things with it to start. Let's bring it over. So we'll sign in here, and single sign-in kicked in. So I'm using a special user called test CAE, and here I'll make a profile API call. So Microsoft Graph is not quite in private preview yet. So it's one of the APIs that will be supporting this over time. But I can show you that it's sort of half implemented today. My test tenant is in the demo in the early group access to this capability, and I want you to note the token expires time frame on the token we just got. So it's about half past the hour or 25 past the hour, but notice that it's going to expire not at 10:30 or 10:25 today, but rather 9:25-ish tomorrow. So effectively, I have a 24-hour token here. I'll do our Outlook APIs as well, just to show you another API that's also enabled, and I get similar results. The token is good until tomorrow, and I can go ahead and get that token. It's good for a long time. So now what we'll do is I'm going to go over and I have my tenant admin here, or my user admin, and I'm going to revoke all of the test CAE user sessions. So I'll go ahead and revoke those. Now we're not quite, we are in preview for these features, so we're not quite doing it instantly. So let's take a few minutes, but let me go ahead here. And first, I want to show you at least some of the code that comes into play here. So we do a normal access token whenever we're about to call a Microsoft Graph API or any other API. We go ahead and do a normal flow, if you will, to get an access token. First off, we attempt to acquire token silent. And if that fails, specifically with something like user UI required, then we go back and acquire a token interactively, passing along what's called a claims challenge that might have come back from the initial acquire token silent call. That claims challenge makes it so so our application would be able to handle, say, the need for interaction because of some conditional access policy or something. So that's the standard pattern you would use. This is a little .NET desktop application to acquire a token before I call, say, Microsoft Graph. What's going to happen, where it becomes interesting, is when I use that token down here to call my API, if my call doesn't succeed, now I have to look for a new header to when I get my unauthorized status code back. So the API call will fail with unauthorized. And if that's the case, I look for my www authenticate header. And if it's there, I can go ahead and look to see if there's an error claim. If there is an error, then I can go ahead and check to make sure that it's specifically insufficient claims. That's telling me that what the error is. And then finally, I can check to see if there's also a claims parameter there. And that will represent something called a claims challenge. And if that's the case, then my application needs to go back and get an access token again, but this time with a claims challenge. So all that's going to happen is we're going to take our claims challenge, which we got off of the response to the call to the API, we decoded it, and then we're going to pass it back to acquire token silent. But now right at acquire token silent, we have our claims challenge to tell Microsoft Identity the nature of why an additional token is being required at this time. If that fails, and most of the time acquire token silent probably will fail, most may be a little bit overstating, but certainly if I've done something like revoke all the user sessions, we're not going to let the token be acquired silently. We're going to require user interaction, and then again, I'll use that same claims challenge to make that call back. So that's the kind of code that we need to go. I'm going to let this sit for just a minute because it takes 5 or 6 minutes for us to get our continuous access evaluation working right now, but we'll move on. We'll come back to take a look at that result in just a minute. I see there is a question here. Does MSAL.js have the continuous access ability? I will check, but I believe it does. It's not specific to the platform it works on. JavaScript apps, it works on native apps. I should have shown you one other piece of code that you need to do, and that is when you do use a MSAL, you have to say you have client capabilities. I'll check to see if MSAL.js has this yet, saying that you have a specific client capability. Not quite sure where CP1 came from, but with that client capability of CP1, you're telling Azure Microsoft Identity that your application has got that code that I just showed you to handle the 401 and the authenticate header. Therefore, we can issue a CAE token to you. So that's really the part where MSAL needs to understand, as well as handling the claims challenges. So looking at, now, if you're not using MSAL and you're doing other kinds of things, I got another question. Let's see. Is there an out-of-box ADEL to MSAL converter? We do have some sample code and some guidance on moving from ADEL to MSAL, but we don't have any tool that would just change your code for you. So back on the resiliency side, so we do have, if we're not using MSAL, there are some additional guidances we can provide you just for the sake of also increasing your resiliency. The first part is making sure that you use a token for as long as it's good for. So as long as it's valid is how long you should try to be using that token. Make sure that you securely cache these tokens, of course, because they are good for their lifespan. And the right place for you to get the lifespan, and this is very important, that you always get the lifespan from the token response. You should never try to look inside of an access token that we give you, open it up, see the expiration time in the token, and work from that. Make sure you always work from in the token response. Whenever we give you an access token, we tell you when that token expires right in that response, and that's the data that you should be using to drive your token caching lifespan and how long you'll cache those tokens. A couple of things here. If you do ask for tokens too quickly, we're rather aggressive with how much we'll go ahead and try to throttle those applications, because you're just hammering the service for no reason. As well as it's just meaning every time if you are asking for a brand new token, you're just increasing your odds that at some point you could see where the service has an issue, the network's down or something, and suddenly your token flow is interrupted and your application may not respond correctly. So the reason, well, I think the question is, why wouldn't you want to open the token? Well, to begin with, we might start encrypting those tokens. So you wouldn't want to do that. If an attacker were to change the token expiration in your response, it really is not that big an issue, because the token is valid as long as the token is valid for. That token validation check is going to happen on the API side. So really where the actual enforcement of a token lifespan happens is on the recipient of the token itself. So if I changed the response and said the token is good for 2 hours and it was really only good for 1, what's going to happen is when you call the API an hour and a half after you've gotten the token, it's going to get a 401 as well, saying, hey, you're unauthorized, at which point your retry logic would kick in and say, oh, the token needs to be updated. So but as opposed to looking inside of the token, first off, again, the idea that we might go ahead and start encrypting that token, making changes to how that token works, is likely to start causing issues for your application in the long term. In addition to caching the token, just say caching those access tokens securely, you also should be securely serializing your tokens. Remember, the token is good for as long as it's valid, right? So if I issue you an hour token, the user stops your application, starts it up 5 minutes later, you have a perfectly good access token. You shouldn't go off and get another token. Again, the more times you go back and ask for tokens, the more opportunity you have to not be resilient, because, oh, I didn't store the token, the user started the app 5 minutes later, and now there's something wrong with the network, or that token response isn't coming back quickly, and now my app's not working when it could have worked just fine if you had just serialized your access tokens. More to the point, of course, is for our refresh tokens. Refresh tokens are valid for days, not hours, right? So it's perfectly sensible that a user signs out of the application in the evening, comes back the next day, signs in, starts up your application again, or starts up their machine again. You should be able to pick up the refresh token, silently acquire a token, and off you go. Now that sounds like, hey, I'm just doing the same thing with a refresh token. But remember, we're going to a different subsection, if you will, of the service. I'm not going to the authorize endpoint. I'm going to the token endpoint. The token endpoint kind of acts more like a REST API. There's not a bunch of UI involved. There's not a lot of other components under the covers. So the making sure that I use these silence options and refreshes can really, again, help increase my resiliency to any kinds of outages back on the service side. And I think Andres is just reinforcing. Yeah, so Andres, I know that it's technically possible that you should look inside those tokens. I'm just vehemently against anyone doing that. So I understand that it's there and that it's tempting, but even just making a decision, like modifying it, sure, you can't do because, that'll be caught through the signature validation. But even just looking at it to make a decision, what if the API designer suddenly decides they don't need that information, right? Because you don't have any control of that token. You have no idea what's going to be in that token tomorrow. The API designer could come and say, you know what, we're optimizing this token, we're taking out these claims, don't need these anymore, aren't working with them. And the next thing you know, your application could end up breaking because you have no control over something that you're asking for to take that information on. So I still am sort of opposed to looking at tokens because of these issues. Now, it is also important that you try to use our silent token acquisition. Again, the first pattern we ask for in MSAL always is to use acquire token silent first. And the reason for that is there's a whole bunch of things on the back end that don't have to be up and running if I can acquire a token silently. So for example, we always want you to start with, if you're at the protocol level, prompt equals none. That's what we do with acquire token silent, because maybe there's an issue with this particular user's getting an MFA prompt over their cell phone provider. And we're going to hit that if we have to have this user do an authentication, which requires an MFA. And now I'm not just reliant on making one network call to get a token, but I'm reliant on the user UI popping up, the MFA service being up, the infrastructure to the phones all being up, the response times, etc. All of that can happen because I didn't ask to acquire a token silently. When, again, we might have been able to do that because you've got your refresh token, or even just asking for the prompt equals none to begin with. Whereas if you do something a prompt equals login, you're causing us to have to go through the login prompt, which might mean off we go for an MFA, and you're putting yourself effectively at the will of the infrastructure between your user and their mobile device in order to pull off those various MFAs. And sure, nowadays things are awfully reliable. There's lots of things there. Just the more stuff you put in the way, the more chance that any link in the chain, if you will, is likely to go down. So defensively, you always want to make sure you use this acquire token silent pattern to start with. And you should really be avoiding prompt equals login and prompt equals consent. If login or consent is needed, we'll look after that. Your application shouldn't be saying, well, I need prompt equals consent, which means we're going to have to prompt the user for consent when we might not have had to. So always do those silent acquisitions to begin with. Now, when you go ahead and make a request of us, you do need to handle those responses correctly. Now, MSAL will do some of this for you. This applies both to Microsoft Graph and to Microsoft Identity as well. You have to look out in case we're sending you a 429, meaning that we're going to throttle you, or we're sending you a response code. We do have a retry after header we would give back. So if you tried to do an authentication and we have an issue, we're going to give back a retry after. You need to honor that retry after. We've seen too many applications who they get that error and they immediately retry. In fact, sometimes they try to pick up the pace and retry as fast as they possibly can because they just feel they have to get that get their retry in. The problem there is, as we see lots of applications do that, if we're having a responsiveness issue, suddenly it's turning into almost a denial of service attack because everyone's starting to pound the service at the same time while we're trying to get, or somewhere along the line, the network is trying to get better or what have you. Suddenly you're generating a lot of extra traffic. So always make sure you honor the retry after header, a response that we give you. So if we say hold off for 3 seconds or 30 seconds or whatever it is, hold off for that time. If we didn't provide a retry after, so supposing there's some issue bad enough that doesn't even show up, then you should use an exponential backoff algorithm. Go ahead and retry after a second, and then the intervals for your retry gets longer and longer as you're waiting for the service to come back up or the issues to get resolved between you and the token issuer. Again, never go off and say, well, I'm going to immediately just right back and get another token, keep at it, and then I'll put myself in a tight loop trying to get these, waiting for the service or whatever's down in between me and the service, because that tends to cause more problems than it's solving for sure. When you're on a mobile device, and actually now with MSAL's support of WAM on Windows, you can start adding Windows to this as well. We do offer a broker model. So there's the authentication broker. It's either the Authenticator app on iOS or Android, or the company portal app on Android, where we send the authentication first to the broker rather than directly to Azure AD first. This helps because these brokers know how to get something called a primary refresh token. And because it has the primary refresh token, we can cut down on how many what we would refer to as fresh authentications are needed. So, for example, when we have access to the primary refresh token, we may know that we don't have to have an MFA experience because we have enough information on the user and the device to know that the effectively an MFA isn't required. So by cutting down, again, the needs for these fresh authentications, you cut down the need of the amount of infrastructure on the back end or in the service or in the cloud that your application is dependent on. So whenever you can, you should try to use one of these brokers if you're on one of these native devices. And like I said, with MSAL a few weeks ago adding the support for the Web Account Manager, WAM, on Windows, now that's also a broker option for your desktop applications as well. I see we do have a comment. Yes, Andres, I absolutely agree. It's your job to look at ID tokens for sure. So great. Yeah, I'm glad we're in agreement there. Is the retry on throttle built into MSAL itself? We do one retry in most MSALs. We're working on adding the better capability there, but the MSALs today will tend to do one. They honor the retry after they try one retry, and that's it. So you would have to do some additional work there. So we are working at making that better, but it is something you have to look into for the retries. Another question, is Authenticator the only broker? Authenticator is the only broker on iOS. I believe we still do company portal, but only on Android. So because on Android, the system is a little more open. They can have multiple implementations. So, but generally it's Authenticator. I will double check to make sure we haven't changed that lately, but that's been the process up till now. Another thing is to think about, when should I use my authorization options? I have various ways I can get information about authorizing the user. So for example, I can ask for optional claims in my token, where instead of making a graph call to get additional information, maybe I could just get that additional information in my claim. There's always a trade-off because graph can be very rich. I can get all kinds of information, stuff that I don't even have available as an optional claim, but it does mean I'm doing another set of calls, right? So the fewer network calls I do, the fewer infrastructure calls I do, the more resiliency. There is a trade-off here that you need to evaluate. So for example, we definitely don't think you should use the user info endpoint. It's there, it's standards compliant, but the information you can get out of user info is already in the token. So we see little need to make that additional call. If you are using groups, one of the issues there is if you use groups that are assigned to the application, so what we refer to as an application group, instead of say, I'd like to see all the user security groups or all the users groups, those can be problematic because the token gets very big and so on. So we actually think using app roles so that the IT folks can use groups to manage, but your application has a smaller, more reliable token because it shows up with app roles are some of the items that you can consider as to what's your best, especially if you're looking for resiliency, where can you best become more resilient with your application? And one option there is to really evaluate, well, when can I get something in the token as opposed to doing it some other way? So let's go back. We've had plenty of time now. We'll go back to our application. Now I know, or at least yesterday when I tried this, the Microsoft Graph API, which has not yet reached private preview stage, is issuing me a CAE token, but not yet handling the events. So I should be able to still call the profile. So you notice the profile called because I have a 24-hour token, and yet I revoke that user sessions. I shouldn't be allowed to make that call. Well, if I go out to the Mail API, which has this capability already enabled, you see that in fact I do get this stop. So I went in, I got my error, I got a unauthorized response code, I found the header, I found everything I needed. I've got my claims challenge, and what I get from this claims challenge is something telling me the information of effectively, hey, Azure AD, when you issue this token, you need to be aware of this not before value you told the API. So it's just a way for us to trigger that. But now, given that that has occurred, I have to go ahead and do my authentication again. I won't even be able to have single sign-on because the sessions were, of course, rejected. So the user does have to authenticate again. That's expected. And now I get my call. And if I go back and look at my token response, of course, I end up getting a new token there as well, or 15 minutes later. I had a whole new token there because we threw out all the tokens once we got the first event. So this helps again, you can see we're much more secure because if we look at the original behavior of that one token, I could still get my profile information about the user because CAE hasn't been turned on for that API yet. But as soon as I did hit a CAE enabled API, the token was invalidated and off I go and get a proper reauthentication. So those are really do help your resiliency because the length of these tokens is so long that we can proactively refresh them. You're not asking for tokens very often, etc. But we can do that because the whole thing is a lot more secure. So what about applications where there are no users present? Well, the first suggestion here is, and this is unfortunately tied to using Azure today, but if you are building your services on Azure, you're using Azure VMs or functions or services, we would really strongly suggest using Azure Managed Identity for Azure resources. First off, they are also more secure. You don't have a password to manage. There's no credentials. You don't have to rotate the certs or anything like that. And there's no way for anyone to intercept that information and use it in the wrong way. We also, of course, are doing additional optimizations. One, of course, is we're issuing long-lived tokens for these identities. Therefore, we'll go through the proactive token refresh. So again, that gives us hours to make sure that the token can be reacquired, and that can really help resiliency. We find anything that's using this process to be rarely affected by any glitches between that token acquisition path. And we even have additional optimizations, things like understanding that I'm an Azure resource, and this resource is running in this specific Azure data center. Therefore, we'll talk to the Azure AD implementation data center for that data center as well. So everything's local is what we would refer to as regional. And that helps reduce any dependency we might have on something outside of that data center. So as long as the data center is up and running my resource, I'll have the right Azure Active Directory to go with that as well. So we can, again, increase our resiliency by not taking cross data center dependencies, if you will. Let's see, so we have a couple of questions here regarding token lifespan. Power Automate allows a user to authenticate to SharePoint. Power Automate will run, for example, every time a SharePoint item is changed. Is there a limit to the authentication? If not, password reset or other stuff like CEE happens, what is the max time frame the token is valid and the user has to re-authenticate the connector? Same thing could happen in your own app. So there is a limitation on CAE. Something like Power Automate won't be able to participate because they're making the calls. CAE not just does token it doesn't do just when the user sessions get revoked, but it also can check for things like IP address changes, and if there's a conditional access policy that says this can only be used from some locations, then a backend process like Power Automate may not be eligible. But outside of that, generally the flow that this works on is access tokens are issued for some specific amount of time. That could be an hour, that could be a day if it's CAE. At the end of that time, we are strongly encourage our developers to use this thing called auth code flow. What auth code flow gives you something called a refresh token. This all is happening under the covers at MSAL. but we end up with a second token. The second token is issued normally for days instead of hours. So if I signed in and the access token was good for an hour, and then something shows up on SharePoint, or and then 2 hours later I do something and then I don't do anything for 3 hours. Well, that original access token has expired, but the refresh token is still good. So the application goes and asks for a new access token using its refresh token. We give it both a new access token, another hour, and a new refresh token. So if the refresh token was issued for 14 days, now we got a new 14-day clock started. So we will roll those, do rolling refresh tokens on those access tokens. So we find, for example, that for most of the time, I think our default is about 90 days before another authentication is required. That is configurable by the tenant. So some of our more security conscious, need to be locked down tenants might set their need for authentications every day, right? So they can control how long they want between a user is required to do their authentication. So you can't count on that time span, but for lots of tenants, you might have your application continue working on that over a month's long period, 3 months or so. Authenticator is a password manager, but I won't be able to talk about that today. There's a new preview feature of Authenticator to also work to be a password manager. It's a nice thing to go take a look at. Go ahead. Can you do an on behalf of flow with managed identities? On behalf of flow with a managed identity shouldn't be required. An on behalf of flow is so that the entity can work on behalf of the signed in user. So the nature here is I have a user who signed in, and maybe that user called my API. So I have a token in hand for that application to call on behalf of the user to my API. Now my API needs to make another call. What we don't want is your API to say, well, I need application permissions. I need to be able to call for any user, because that breaks our model. That breaks the security envelope. Instead, we want your API to say, well, I'm going to call Microsoft Graph, say, but I have to do it on behalf of the signed in user. So here's the token that the application gave to me, so that the application called on behalf of the user to my API. Please give me a token so I can call on behalf of the user to this Microsoft Graph API or whatever other downstream API I want. A managed identity has never got a user in front of it, and it shouldn't be working even in a service account if that can be avoided at all. Therefore, they shouldn't be looking at an on behalf of flow, because it's all, they just needed a token, they just go ahead and use the token. And since we're, as part of the nature of managed identity for Azure resources, we're actually doing all the token acquisition, low-level protocol stuff for you. You go to an easy access to the token, and we just give it to you. So we're refreshing it and so on is something we're already handling. Does it exist a way to authenticate external users outside of my company without using Federation and Azure AD B2C? If I invite users as guests, they can access to our internal applications like Office Online. We do not like this to happen. So a guest user does authenticate back to their original authentication point. You would have to control that through conditional access or by user assignment is usually the point. So one of the things that I see lots of customers doing is requiring user assignment to any app, and then they can simply have a group of guests and they have a separate group for people who are not guests, and those are the apps they assign to people for whom guest apps shouldn't be accessible. So you can control that at the IT admin side by using things like assigning users and groups to apps. So the default would be 90 days and not longer. So depending on the policy, it is possible we'll keep issuing tokens on that rolling refresh. 90 days is our default. Some of them are 14 days now as well, depending upon the configuration of the tenant and what the options they've picked. And then again, they have another knob that says I want to do it this way. So a couple of more points again. If you are writing an application that's not using, maybe you're not running on Azure, so you can't use a managed identity. Another good step here is to use MSAL. We do all of the same work we did for client applications for what we call confidential clients. These are the ones that are using client credential flow. So we have a similar set of capabilities that will work for these daemon or service apps in MSAL. So it's another choice. Otherwise, it's pretty much the same kind of guidance. cache your tokens correctly, and so on, because you are still doing, how often you make a token call is going to help with your resiliency. So we have a few minutes left. Any questions? Any other questions? I appreciate everyone's time today. I know everyone's busy nowadays, so I appreciate coming to our session today. Stephen, did you have any wrap-ups that you wanted to cover?
Yeah, just want to thank everyone, and remember to please take some time to fill out a survey. Just take a few minutes and give us feedback on this call, and if you have ideas for future topics. I'm also going to post the link where you can watch the recording next week. And so thank you, everyone, and we hope to see you in our next call on March 18th. Appreciate it.
Thanks, everybody.